Welcome back, students. In the last class, you saw the degrees of polynomials and how the polynomials are classified based on the degrees. If it has degree 1, then linear polynomial, degree 2, then quadratic polynomial, degree 3, then cubic polynomial, and degree 4, then biquadratic polynomial. And if degree is 0, then constant polynomial. And for 0 polynomial, degrees not defined. Up to this you have seen. Today's topic is polynomials in standard form. How do we represent a polynomial in standard form? For everything there is a standard form, and for representing polynomial also there is a standard form. You can write polynomial as 7x cube plus x plus x square plus 17x to the power 5 plus 5. This is a polynomial, no doubt, because every term has a variable except this term, and those variables are having powers which are non-negative integers. So obviously this is a polynomial, this algebraic expression is a polynomial, but this is not arranged. This is a very de-arranged form. See here, x to the power 3 is here, x to the power 2 is here, x to the power 5 is here. So if we arrange it in a fashion, either in ascending order or descending order of the powers, here it is 17x to the power 5. So if we give priority to this, because it is the term having highest power of variable, that is 5. So if you write it as 17x to the power 5, and then the term containing the highest power of variable is this one, so we write it later on 7x cube, and after that this has the highest power after these two, so we write this term, this is gone, this is gone, this is gone. What is remaining? X. It has power 1 and x has power 0 here, so x plus 5. If we write like this, if we arrange the polynomial of this form to this form, and this form is called, this is the standard form, and in this way you have converted this polynomial into its a standard form. It is not the only standard form. You can also write 5 plus x. You can reverse this. (17x to the power 5). Even in this case, you find a particular fashion, that is the power of x is 0 here, then power is increasing 1, 2, 3, 4. So either you write or rearrange the polynomials in the ascending order of powers of variables, the ascending order of what? Power of variables. Power of variables, or like this case, descending order of power of variables. Either you arrange it in ascending order of power of variables or in descending order of power of variables. It will be called polynomials in a standard form. This is quite simple. So what general form you find here? The general form you find here is for descending. First take ascending, it will be easier for you to consider descending. Ascending we have only one constant and variable has a power 0 and it is not represented because variable to the power 0 becomes 1. If I were to show it here, x to the power 0, next time the coefficient can be any other coefficient. It can be same but it can be different. So let's take if it is different or the value of both of them is similar. This time power will increase. Maybe in the given question or even in the given example you do not get x to the power 1 only, but it should be in the ascending order. If it is x to the power 2, then x to the power 5, then x to the power 7, and then x to the power 3. Then it is not in the standard form. You have to arrange it in ascending order of powers or descending order of powers. If you are ascending the order, if you are arranging it in ascending order of powers, first this will come, then this will come, then 5 will come, then 7 will come. It is not necessary that each of them will come, but for to give a general formula, to give a general form, we have so you see when we are taking a0 x power 0, a1 x power 1, so it will go up to an x power n. So this is the general form of, this is the general expression for the polynomials in a standard form. This is the general expression for polynomials in a standard form. But this is not the only general expression. This is the case of ascending. Similarly, the case of descending, reverse it. The highest power an x to the power n, 1 less than this, and so on till a0 x power 0. Isn't it? So the standard form can be either in the form of descending order of power of variables or ascending order of power of variables. This is all about the polynomials in a standard form. You may be given a question and you have to arrange it in a standard form. In many cases, arranging the polynomial in a standard form helps you solve the problem easily. Next, we will see the types of polynomials. This will also be a recap or revision for you. Polynomials can be classified on the basis of terms. They can also be classified on the basis of variables, and they can also be classified on the basis of degrees. On the basis of terms, if it has one term, then it is, if the polynomial has one term, it is monomial. For two terms, the word is binomial. For 3 terms, trinomial, and for higher number of terms, for 4 or more terms, it is simply called polynomial. No other specific name. Variables. Based on variables, it can have 1 variable, 2 variable, 3 variable, any number of variable. So it can be polynomial in 1 variable. It can be polynomial in 2 variable. It can be polynomial in 3 variable, and so on. For one term, what can be the example? It is very easy. You have to print only one term. 2x, simplest example. For binomial, 2 terms. No issues. 2x plus y. There are 2 terms. Trinomial, 3 terms. No issues. X square plus 2y plus z. And for 4 or more, x square plus y square plus 2xy plus 2yz plus 2kx. Polynomials in one variable. So variable should be 1. It does not depend on the number of terms. Number of terms can be any number of terms. 2x plus 5. This is a polynomial, and here only one variable is there. 2 variable, x plus 5y. 3 variable, x plus 5y plus 6k. So here we have 3 variables. You can also write x square, x cube plus x square plus x plus 5y plus 6k. Here terms are 1, 2, 3, 4, 5. Terms are 5, no doubt. But the variables used are x, one is y, and one is k. 3 variables. So this will be polynomial in 3 variable. This is all about the classification of polynomial on the basis of terms, then classification of polynomial on the basis of variables. Next is classification of polynomials on the basis of degrees. So just you have studied degree is 1, then linear. Degree is 2, then and degree is 1, linear. Example of linear, you have to keep the degree 1. That means you have to keep the maximum power as 1. Power of variable should not be higher than 1. So let us take 2x plus 5. X is a variable whose power is 1. We do not have any other variable which has a power more than 1 here. So it is linear. Quadratic, the power can go up to, the variable's power can go up to 2, cannot exceed 2. So the degree 2, the name is quadratic. X square plus x square plus 5y. This is a quadratic polynomial. This is a variable. This is also a variable. The highest power of variable is 2. We have not exceeded it. cubic x cube plus x square plus x plus 5. Highest power of variable is 3. Linear quadratic cubic, then degree is 4, then it is biquadratic. X4 plus 5. This is also a polynomial. The variable has a power of 4. Variable has a power of 0. So highest power of variable is 4. So therefore this is a biquadratic polynomial. So this is all about the types of polynomial. In the next class we will see some of the questions based on polynomials. Those will be our first set of questions based on polynomials, the introduction round. So let's see you in the next class.